is showing here. Okay, so this is actually a basic card that is showing that the CPU bus is actually showing in the x axis, and in the y axis we are showing the frequency. Okay, and how it is increasing or decreasing, that thing is shown here. Okay, so that was not very much important. So I am going to the part of the CPU scheduler. Okay, so CPU scheduler is also called as the short term scheduler. Okay, and there is another scheduler, that is the long term scheduler, that is called the job scheduler. Okay, so what is the purpose of the CPU scheduler? The CPU scheduler can select any process from the memory that are ready to be executed and allocate them to the CPU. So the task of the scheduler is that to actually take the process from the memory, because the memory is containing the processes. Okay, and from there, when the process will be executed, when the process will be given to the CPU, the CPU will one by one execute the process. Okay, so first of all, the state, that is, you can see, so this is actually the diagram, that is the process state diagram, where we have new, ready, running, here is waiting, and then terminated. Okay, now when the process is new, it is going to ready state by the admitted, means the process is admitted from new to the ready state. Then from the ready state, whenever it is going for running, then it is called the scheduler dispatch. And from running to the ready state, it is the interrupt. It is possible. Okay, sometimes this may happen that interrupt is occurring. Okay, any software interrupt or hardware interrupt is occurring at that time. This will be from running to ready. Then we have the IO event. Okay, IO event wait or IO completion. So when the process is coming from running state to the waiting state, then it is IO or event wait. And when it is going from the waiting to the ready state, then it is IO or event completion. And finally, from the running state, it is going to the terminated state. Okay, so that is possible. It is showing here. You can see it is running to waiting. Okay, running to waiting, it is possible. Okay, it is coming, or it is coming from running to ready state. Yes, it is possible. Or it is happening that waiting to ready state. So waiting to ready state, possible. So and also running to terminated state. So basically from ready to running, then running to ready, and then from running to waiting, waiting to ready, and then running to terminated. Okay, in this way the processes will be executed one by one. Now we can, this thing is already told to you, that is a non-preemptive and the preemptive version. Non-preemptive means that if this thing happens that any process get the CPU, so 1 and 4, that is that 1 and 4 is the non-preemptive, means this one and this one. That means the process is going from running to waiting state and then running to terminated state. Okay, if this thing happens, then this is the non-preemptive. And preemptive means that running to ready state and waiting to ready state. These things are the preemptive version. So that means they are telling that this may happen when the process get the CPU. Okay, some other process may get the CPU. Okay, that is the preemptive. Okay, so during the execution without completing the current process, the CPU is leaving the process and going to some other process, and again it will take the previous process. Okay, and execute one by one. Now the concept of dispatcher is there. So where is the dispatch? I told you that dispatch is in this part, that is from the ready state to the running state. That means when the processes are waiting in the ready queue, they will be called by the dispatcher or the scheduler dispatch, that will take the process from the ready state to the running state. Okay, so you can see that this thing, the dispatcher module keep the control of the CPU to the process selected by the short term scheduler, and this will involve switching context, switching to user mode, and jumping to the proper location. Okay, in the user program to restart the program. So these are the things that are involved here. That means first one is switching context, switching the user mode, switching to user mode, and jumping the proper location, jumping to the proper location in the user program, and to restart the program. Okay. Now the dispatcher needs to run as fast as possible. Okay, that means this dispatcher will actually run very fast since it is invoked during the process context switch. Context switch means actually what? Context switch means that one process has either finished or it is went to the waiting state. At that time, some other process will come from the ready state to the running state. Okay, so from the running state there is two arrow. One is to it is going to the waiting state, or it is going to the terminated state, or it may happen that directly it is coming to the ready state. Okay, because of some interrupt may happen, and due to that the process is coming from the running state to the ready state. It is coming back. So in that case, so it has to be, the dispatcher has to be very fast, because that when the context switch will happen, the process context switch will happen, the dispatcher will take some other process for the execution. Okay. Now, the time it takes for the dispatcher to stop one process and start another process is called dispatch latency. Okay. So we can see that what is the dispatch latency? Dispatch latency means that when the process is actually suppose going from, means leaving, when the CPU is leaving one process, okay, and it is going to take another process, okay, then that will be the dispatch latency. That will be the dispatch latency. Okay, so the time it takes for the dispatcher to stop one process and start another process. Okay, if you stop one process and go to some other process, then that will be the time required there, that will be the dispatch latency. Okay, some criteria are there for the scheduling, that is you can see that different criteria for the CPU scheduling is that number one is the CPU utilization. Okay, that means the CPU can be utilized as maximum as possible. Okay, we can keep the CPU in busy state. Next one is the throughput. Throughput means actually number of process completed per unit time, that is the throughput. Okay, suppose in a second, suppose we have completed 5 processes, then 5 will be the throughput. Okay, response time means that the time required to give response. So that means any process, the execution of the process will start, okay, from which place or which time, that will be the response time. So suppose you have 5 number of processes, P1, P2, P3, P4, P5. Okay, so the process that is actually will be taken to the CPU for execution, that time will be the response time. Okay, then we have the waiting time. Waiting time means that when the process is waiting for some IO completion, at that time, that will be the waiting time. Means that process has entered to the ready queue, okay, and it is waiting to be executed, okay, or waiting to be fetched by the dispatcher from ready state to the running state. That is called the waiting time. Okay. Also, this may be waiting time also. This is one waiting time. We can say another thing, that when the process is going from the running state to the waiting state, and it is waiting for some IO to be completed, means input or output to be completed, at that time, that will also be termed as a waiting time. Then the turnaround time means that the whole time, that is when the process came to the ready queue and the process left the ready queue, okay, after the completion or after the execution, that is called the turnaround time. Okay. Now, optimization criteria are there, that is, these are desirable here. Maximize the CPU